So in this session, let us solve some more problems on transient analysis, okay, and switching networks, and this time consisting of uh, capacitance, inductors, resistances all together, okay. So here the arrow indicates that the switching is happening from A to B at time t equal to 0, and you have to find this voltage, okay. So basically you have to find an expression for that voltage. Happens before closing the switch, or what happens before changing the switch position and after changing the switch position is what we have to check, okay. So when t is equal to 0 minus, how do I draw the circuit? It will be like this. The switch position A would be there, and then since this is not connected, this B is not connected, so this whole part will be not in the circuit, right? And you have this resistance of 1 ohm. There's a 1 Henry and the voltage is 1. Okay. So before closing the switch, the circuit is in steady state. And in steady state, what is an inductor? How does it behave? In steady state, it's like a short circuit. So this is as good as a short circuit. That means this circuit will only have a voltage and the resistance. And what will be the current flowing in this part? In the inductor? 0 minus, that will be 1 by 1 volt. 1 volt by 1, that is 1 amp. Is this okay? And what will be V2 of T? Because you see here, initial current in the 2 ohm inductor, sorry, 2 Henry inductor is 0. What will be the drop across this inductor? 0. So V2 is also 0. Is it making sense?
Yes, ma'am.
Okay. Now redraw this circuit for T equal to 0 plus. So what happens for T equal to 0 plus? Now the switch would be like this. Like this. Is that okay? What is the current in this inductor? In this inductor? In this inductor now?
1 ampere, ma'am.
Because this is 1 ampere. Before switching, it was 1 ampere. So after switching also, this is 1 ampere. Correct. And what will happen to V2 of T? V2 of 0 plus?
1 by 2 volt.
Why is it 1 by 2 volt?
Because the 2 Henry inductor will be act as an open circuit. So 1 ampere current will flow through the half ohm resistance. So
Correct.
V equals to IR, 1 by 2 into 1 is 0.5 volt.
This will be 0 plus this current here. I of 2 Henry at 0 minus is equal to 0 ampere. This is given in the question. Initial current in the 2 Henry inductor is 0. So even after switching, even after changing the switch position, this inductor will not allow a sudden change in the current. So it will continue to remain 0 volt. Okay. Sorry, not 0 volt, 0 ampere. That means there is no current flowing in this part. So whatever current is flowing through this, flowing in this 1 ampere, okay, will continue to flow like this through this resistance, because there's no current in this. There can't be any current in this. So at this instant, right after closing the switch or changing the switch to B position, this current has to flow like this. Okay, but you see how I have marked the polarity. So what is this? This is plus and minus. So will it be 1/2 into 1 ampere, but in the negative direction? Is it clear why it is negative direction? The current would flow like this, right? So the actual polarity would be like this, which is opposite to the polarity marked in the. Is it clear?
Yes, ma'am. Minus half volt.
Minus half volt. Oh, sorry, half volt, yes. Not ampere, half. There are two inductances. When the switching happens, both the inductances will try to maintain the same current right after the switching happens. So 1 Henry is carrying 1 ampere current and 2 Henry is carrying 0 current. So accordingly, your V2 will get modified to minus half volt. So here now we have to draw another circuit which will be corresponding to time t greater than 0. That means after switching, again the steady state is attained. So this was steady state. This was the steady state. This was that in switching part. Okay, this one. This is where the switching is happening. And then again it has to be back to steady state after switching. So again steady, and that would be t greater than 0. And how will I draw the circuit? It will be this inductor. Okay. This, and you have to show that current source also. How is the current source? Down. This is the initial current. Okay. So in integration, when you have learned integration, if we use the indefinite integral, we have that plus c, right? Integration constant or some constant c that we take, that actually corresponds to the initial condition. So that initial condition also have to be considered in the circuit when we write these differential equations. So plus minus V2 of t. We would have written another current source like this if it had a value, but here it was 0, so I'm not writing it. So this is 2 Henry, this is 1 Henry, half ohm. Okay. Now you have to form a differential equation for this circuit. So,
Ma'am, excuse me. V2
yes,
was minus half volt, right? Like 0 plus.
correct.
So we won't keep this in series here.
We won't keep series. Which one in series?
2H like with the inductor.
No. Currents always in parallel.
Oh, got it. No. I was asking about
Voltage.
the voltage should be there or not. Like.
This voltage is there.
Okay. Like. Okay, only the current.
Okay. You are saying voltage source.
Yeah.
No. That is when you had a capacitor and you were trying to find the capacitor voltage. That initial voltage of the capacitor will come in series. Here,
Yeah.
this is not initial. This is not the capacitor voltage, right? This is a
Yeah.
voltage across the parallel combination.
Yeah, I got it.
Okay. Now you write the KCL at this node. Okay, at this node, you write KCL taking this as the reference. Okay, so for the all of them have this voltage as V2 only. This potential here is V2, right? This potential here will be V2 only because we are calling this as reference 0. So if this is 0, this will be V2. So all of these will be at V2 potential. So first 1 by inductance integral V2 of t dt minus plus 1 ampere plus V2 minus 0 divided by the resistance half minus 1 by 2 Henry integral V2 of t dt equal to 0. Any doubt in how I have written this expression? There are 4 branches at this point. This is one branch, this is one branch, this is one branch, and this is the second, another fourth one. So 4 branches, so 4 terms. And we are writing KCL, so current expressions. Current through, we know that VL is equal to L di by dt. So current in an inductor will become 1 by L integral Vd. And what is V in this case? V is V2 across all the components. So we get this. Okay. So form a proper differential equation by differentiating both sides. So you get this as V2 of t plus differentiation of 1 is 0 plus 2 dV2 by dt minus, no, plus, sorry, plus, this is plus half V2 of t equal to 0. So 2 dV2 of dt by dt plus 1 by 2. Three by 2 V2 t equal to 0. Or let us just remove this and make this 4 and you get this expression. Is it okay? So how do we solve this equation? This is a linear equation. Okay. Linear equation in a linear differential equation, first order linear equation. So here, this is P. So you have this integrating factor. I think I had given you this, how to get the solution. Integral P dt, that is integral e to the power of 3 by 4 t is the integrating factor. Okay, so the solution would be V2 of t into the integrating factor equal to Q, which is 0, into the integrating factor. Okay, Q, this is Q, plus some constant, let us use K. Okay, let's not use C because C represents capacitance also. So V2 of t will be equal to, this is 0, first term is 0, K e power minus 3 by 4, this. Okay, now we have to find the value of K, which is our arbitrary constant. So do we have any initial condition? We know that at t equal to 0, V2 of 0 here, you see here, V2 of 0 is minus half. Right after closing the switch, the first value of voltage that appears is minus half. So this is minus half. So I can use this here. So minus half equal to K e power minus of 0. So K is equal to minus half. So what is the expression for V2 now? Minus 1 by 2 e power minus 3 by 4. Okay. Is this clear? Now looking at that expression, this last expression, can you tell me what do you conclude from here? Like what do you understand? What is your inference?
Voltage is exponentially decreasing, but minus is there.
That
Okay.
minus is because initial value of the voltage was negative half, right?
Yeah, ma'am. Yeah.
This is the initial value. It could
Yeah,
be
ma'am.
positive or negative also. And negative is just because the polarity is the opposite of what is shown. If we had marked this as negative and positive, this would have been positive. Okay. So what is happening here? V2 is initially minus half and then it is exponentially decreasing. Okay, what is the time constant in this case? Do you understand what is the time constant?
4/3.
Minus 3
4
by
by 3.
4/3, correct. So in this case, the time constant is 4/3 seconds. Okay, so time constant is 4/3 seconds. It's an exponentially decreasing, and it starts with an initial value of -0.5. Okay, volts. Why is it exponentially decreasing? See, this current it's not actually the source. It is that initial current. So other than this, there is no source in this circuit. Okay. So, and since the resistance is there, the energy or the power keeps getting dissipated, right? It keeps getting decreased. Your amplitude, it kind of damping happens. Okay. So amplitude would keep decreasing. Eventually that energy will be lost. Okay. So the voltage value also correspondingly decreases, and that decrease is exponential in nature. Is this clear? So this is the expression for V2 for this circuit. Shall we go to the next problem? If you're noting down, let me know once you're done. So we started with this circuit. When changing the position, you have to find what is V2.